Okay, good morning everybody. We're going to start 4.3 now. Hope y'all are all doing well, and hopefully this lesson will go pretty quickly and you get some good information out of it. So first we're going to start looking at the graphs of the sine and cosine. And so the first one we're looking at is the graph of sine. And so before we start actually drawing this out, I wanted to look back over here at the unit circle, because that's how we've been defining it so far. And so I have a little one up here drawn. And basically, when we start off with sine values, remember the sine values are the y values at coordinates. So if we start off at an angle of 0, we're right there. And if we look at this and we come all the way over, we're at 0. So sine is going to start at a value of 0. So at 0 angle and 0, at 0 angle, we get a 0 result, and that gives us this point right there. Okay, then as we start to move up a little bit, we start to increase our angle, we move a little bit, what happens is we start moving up on sine, on y, and you can see we got a little higher there. And so that might correspond, I'm sorry again, my dog started barking, but that might move us up a little bit over to there. And then as we continue on around the circle, you'll see that our values continue to get higher and higher, right? And then we move up a little more, and we get to there, and that's like this point. And then we finally move up a little more, and we reach this here. And this is our maximum point. It's our highest point in the y-axis, and that's right there at 1. Then if we continue increasing, we're going to start heading back down. See that? We're moving down a little bit below 1. And then we're going to move down over here, and now we're a little bit further back down. And then we're going to move down a little bit more, and we're getting further and further down until we finally ultimately come back down, and we're at 0 again, right down here. So I'm kind of making these points darker. And then we're going to move to the negative side as we continue around. And you see this? We're getting negative, so now we're down here at this point. And we keep going around and keep going around like this, and we get all the way back down to 1. So we go to here, here, and we get down to -1 when we reach there. And then if we continue on around again, we just keep going like this, step, 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 getting lower and lower, or at least closer back to 0. And we're going to go right up, and if we plot those out just like that, we'll have those points until we reach all the way back around to where we started at 0. And then if we were to continue going around again, we would start doing the same thing. We would go, we would start heading back up to 1 and back down to -1. And then even if we rewound and started going in negative directions, if we started going around the circle in the negative direction, we would start off going negative, down to 1, and then curving back up like this. And so we would be plotting out all these points. And if you notice, as we plot these points out, it looks like a wave. And in fact, it's quite often called a sine wave. And so if we draw this in, we end up with what is called a sine wave if we were to stop and do every single point. Okay? And that's what a sine wave looks like. It'll start, oops, that last little part wasn't good. It'll start up here at, over here at 0, 0, and then move up to 1, back down to 0, down to -1, right, as we go along, and then back up to 0, and then up to 1, and it's going to go through this cycle. It's what's called a periodic function, a periodic graph. It goes through cycles like this. And so you can see in this table on the left where different values of x are plugged in, which would be like our angle, and we get different values of sine. And as you notice, it goes up to 1, back down to 0, down to -1, and so on and so forth. There's a few things we can name off of this graph. First off, if we go through one full cycle, in other words, starting at 0 and going back over to 0 again, going through one full wave, that we can actually call the period. In this case, not always, but in this case, this period equals 2 pi, because we started at 0 and we got over here to 2 pi before we finished one full cycle and it repeated. All right. We can also name the amplitude. This is essentially from the x-axis, from this x-axis, it's either how maximum high above it we get or below it that we get, that is called our amplitude. Now, in this case, our amplitude equals 1. And so, we basically have those couple of definitions, and we'll see them here as we go below. Now, if we look at this, the domain is going to be negative infinity to positive infinity. We can plug anything we want in for x. The range, however, you notice, our function never goes below -1, and it never goes above 1 here. So we're basically trapped. It goes up to 1 and including 1, and down to -1 and including -1, never outside of it. So our range is going to be inclusive of -1 to 1 inclusive, just like that. We can also notice that we have a bunch of zeros in this. If you look at this graph, you're going to be crossing the x-axis and having zeros here, 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 and then again out over here, and so on and so forth. And we're going to basically have an infinite number of them. However far forward and back we go, we're going to see all these zeros. And if we look at this, we'll notice they occur at 0, then at pi, then at 2 pi. This one would be out here at 3 pi. If you go the other direction, it's at 0, then it's at -pi, and then there'd be one at -2 pi, -3 pi. So they're occurring at multiples of pi. This graph has an odd symmetry to it. It's an odd function in that it's symmetric over the origin. And when we say it's odd, what we mean is sine of negative x equals negative sine of x, right? It's an odd function. As I stated up above, the period is 2 pi. You're going to want to be able to identify that. So you're just basically looking until it repeats itself. Now be careful when you do this, because if we start looking here at the origin, notice the function is headed up. And you might be tempted to stop here when you get back to the origin again, but notice the function is headed down, so that's not a full cycle. You have to keep going until you get back to the same point here again, and it's headed back up. So this point here and this point here, that's the beginning and end of one full cycle. All right, you have to do one full complete wave in order to make note of what the period is. Last we have here, what is the amplitude? And I pointed that out on the graph up there. It was 1. Okay, so that is our sine function. And just one last little thing I want to say about the period. When we're talking about a period, we're talking about the amount of time, usually time, like if x was time, the amount of time to complete one cycle. Now, it doesn't always have to actually be time. It could be something else. But basically, when we look at that x-axis, which usually is time, when we're talking about period, it's how long it takes or how far you have to go until you complete one full cycle. So if you think about things like the period of Earth's orbit is 365 days or 1 year, the period of Earth's rotation is 24 hours or 1 day, and things like that. That's how long it takes until it starts to repeat its cycle. Okay, so I'm going to go ahead and go over here to the next page now, and let's take a look at the cosine function. So I'm going to draw another circle here, and this will be our unit circle again. And we want to kind of go around it the same way we did, but for cosines. Remember, cosines are your x values. So if we start at the same location over here at 0, we notice our x value, right? This is the x-axis. We notice our x value is all the way out here. It's at 1. And so that's our first point there, 1. And then as we continue to move up around, I won't do it quite as detailed as I did before, we notice that all our x values keep getting smaller. We're here, then we're here, and then we move around, and we're here, and then we get all the way up to here where we reach 0. So we're going to just kind of go down a little bit until we reach 0, and that's when we're at this corresponding point up here. Then as you continue on around, the x values will start to increase, but in the negative direction. Notice that we're going out this way, x, x, x. We're getting more and more negative this way, okay? And so here on the graph, we go down into the negative side until we reach -1 all the way over there at -1. Then as we continue around the circle, we're going to start to become less negative. Notice we're heading back toward the y-axis. So we're getting less and less negative this way, where we're ending up here, you know, closer and closer. We're moving this direction toward that. So we become less negative back towards 0 until we reach 0 right there. And then we're going to continue on again around and around and around, where x values are going to start to increase again until we reach the value again of 1. And if we were to continue going around, these would continue cycling up and down just like that. And if we had gone in the negative direction, they would cycle down around like this. And this is basically our cosine function and what it looks like. And so if we draw it in, we get a wave. It looks just like the sine function, except it starts at 0, 1. It starts over here at 0, 1, instead of starting back over here where this started at 0, 0. See the difference? This one starts at 0, 0. This one starts at 0, 1. We can still name a period. We can start here at the origin. We're at the highest point. We're at a peak here. And so we're going to go along until we repeat, which is over here at this peak. And this will be 1 period. And again, for the standard cosine graph, this is just a period of 2 pi, which is, of course, the number of radians it takes to go around a circle. Again, we're going to have an amplitude of 1. Again, we go the furthest distance up or the furthest distance down we can go from the x-axis, or also what is known as equilibrium, if we shift this from the x-axis there. And this is our amplitude. And it, again, has a value of 1. So now if we go down here, we can start figuring out some of these properties. The domain is, again, -infinity to +infinity. We can plug in anything we want, and we'll get a result. The range, again, is staying below 1 and above -1, and inclusive of 1 and -1. So it goes from -1 inclusive out to 1 inclusive. The zeros are occurring here again. Notice they're occurring same kind of separation, right? And this one would be back here, and there's one here. But notice they're happening at the pi over 2's. This one is pi over 2. This one's 3 pi over 2. This one's 5 pi over 2. And so essentially they're occurring at every other pi over 2. Okay? So they're occurring at multiples, or at least at every other multiples of pi over 2. So you start at pi over 2, and then you don't stop at pi, but you go to 3 pi over 2. So all the over 2's they're occurring at. This is actually an even function. So cosine of negative x is going to equal cosine of x. And so it's an even function, and so it's symmetric over the y-axis. And it has, again, a period of 2 pi, as we stated above, and an amplitude of 1. Okay? So once you get these two basic graphs done, these two waves, and know these properties of them, it's simply a matter to do these graphs of following the same transformation rules that we have done before. First off here, A is what A, the number out in front, is called the amplitude. And if you think about it, it has to be, because remember, our functions go from -1 up to 1. And so this, essentially, putting that out in front of the whole function, is the same thing as A times f of x. And what it does is it causes a vertical stretch, all right, or a vertical shrink if it's a fraction. It's a vertical stretch or shrink by the amount A. And since this is already going from 1 to -1, anything you multiply 1 or -1 is just going to be stretched by that amount. So if we put a 3 out in front, instead of going between, instead of going, 1 above the x-axis, it's going to go 3 above it because it's going to be stretched up 3 times. So this is a vertical stretch or shrink, and it tells you the amplitude right out there at the beginning. It tells you how high above it goes. So if there's a 3 out in front, you got to go 3 above the x-axis and 3 below it. So it'll go between 3 and -3. B, that number in there, affects the period. Okay? This is kind of like an f of b times x, and this corresponds to horizontal stretches and shrinks. Okay? By horizontally stretching or shrinking it, we are going to change the period. And in fact, the period can be obtained by this by doing period. The period is going to equal 2 pi over b. Because if you think about this, all right, that's important, this idea. Remember, whenever we multiply a b, whenever we did this kind of a horizontal stretch or shrink, we did the opposite of what was there. So if b was a number greater than 1, it would be a horizontal shrink, which is why the period gets divided by b. And if b was a number less than 1, if it was a fraction, then we'd end up dividing by a fraction, which is multiplying by the reciprocal, and we'd end up getting a stretch here. So if we divide by b and b is less than 1, it's going to stretch it out and give us a longer period. If we divide by b and b is greater than 1, it's going to compress it down and give us a shorter period. So we divide by b, just like those rules. It's horizontal, so we do the opposite of what is there. All right. Next, c from the function is what is called a phase shift. And it's in the horizontal direction. This is a lot like f of x minus c, basically a horizontal shift, working just like the horizontal shifts before. We're just giving it a new name, calling it a phase shift. And then the last one, d, is also, we can call it a phase shift, but it's a vertical one. In the vertical direction, it's a vertical shift, and this corresponds to f of x plus d right there. And that would move it up or down vertically from the x-axis. So let's take a look at this first graph here. We've got regular old cosine of x. So the very first thing I want to do is just sketch in the cosine function. So if this is 1, this is going to be -1. Now remember, cosine started up here at 0, 1, and then as we went through, I'm going to call this pi over 2. Actually, I don't need to write all of those. We're going to make this, each one of these, a value of pi. So this will be pi, this will be 2 pi, this will be -pi, this will be -2 pi, like that. And then our function goes up and down between 1 and -1 every 2 pi. So what's going to happen is it's going to go down just like that. If you don't remember this, go look back at that second page where we did the cosine, and it's going to look like that, okay? So something like that. Our wave, just like this, maybe it, we can show it goes on down like that and continues on and on in that fashion. So there's our base function right there. So let's first start by figuring out everything that's going to go on. So some of the things we see here that we're going to have to do, we're going to have to go up 3. Okay. We've got this, we have cosine of 2x plus pi, but if you look back up here, look at how this is. This b is out in front, and then x minus c. So we need to change this a little bit. So what I'm going to do is take this 2x plus pi and write it as 2 times x plus pi over 2. All right, in that form, then this pi over 2 tells me left pi over 2. I have this 2 out in front, which I can use this relationship right here. Period is 2 pi over b. That means that we'll have a period, right? A period equal to 2 pi over 2, which is just going to be pi. So instead of repeating after a 2 pi amount, we're going to repeat every pi amount. And then lastly, we have an amplitude equal to 2. All right, so instead of 1, we're going to have an amplitude of 4. Or an amplitude of 2, sorry. It's going to go stretch a total amount of 4. So for these, we can just simply move it left pi over 2. That's going to be that. Maybe I'll do this color-coded. Let's do, I think that's going to be left pi over 2. That's this part. Then we're going to go up 3. 1, 2, 3 to right there. So that's the up 3, okay? And so that puts our starting point right there. That's where the origin, that origin right there, moved to. And so now we have an amplitude of 2. That means we have to go up. We have to go up 2 above that, because our amplitude is 2. So let's see here. Let's make that a color. Let's make this amplitude of 2. That means we have to start here and go up 1, 2. That's our amplitude. So this will be our peak starting point right there. So we'll be up 2, and then we're going to go to down below 2. So basically we have to stay between this and this as we draw it. All right? And this is our amplitude because this was our new little origin. So we got to stay between there and there as we draw it, up 2, down 2. And then finally, we need our period, which I will mark in yellow. The period has to be pi. And so every pi, we're going to have to totally repeat. So we're starting here. Each one of these tick marks with a pi over 2. So this is a pi. That's a pi amount. This over here is a pi amount. Then we've got another pi amount. Oops, nope, that was the wrong amount. From here, every 2 ticks is a pi amount. All right? And so now it's just simply a matter of drawing in our new function in there. So basically, I'm going to start up here. This is my starting position because it starts at its amplitude above our origin, or our new origin, our starting point. And it's going to go down. There's half a wavelength, and then back up. There, I've completed one full wave in a pi. Let me make that in yellow. In a pi amplitude there. And so now I just need to keep doing that. Repeat down, back up. Down, back up. Just like that. And then in the other direction. Down, back up. Down, and then back up. And there we go. That is our graph there in red. I know it's kind of messy, but that's okay. Here in red, this is our actual graph of the function there. So we did our regular old shifting around. You got to know that base function, and then we did all our transformations that we've done before, and ultimately ended up with the function right here. The 2 cosine 2x plus pi plus 3. And that's what the graph would look like. Okay? So be sure you practice some of these, get them done in your homework, and make sure you can actually do these graphs. The next thing you might have to be able to do is to actually write an equation given a graph. So let's first go ahead and let's look at this graph. And the very first thing we can do, and now let's be a little careful because there are actually, you could write sine or cosine for any of these. So you might be specified, like for this one, it say write a cosine. Or if it said write a sine function, it would have to be a sine function that was shifted horizontally. Because when we look at this, we're not starting at 0, 0. We're starting at 0 and then an amplitude above 0, 0. So this to me looks immediately like a cosine graph. Now you could make it a sine graph by having a horizontal shift in it, because the sine graph would have started like this and done like that. And then you could have actually just shifted it horizontally to the side and made it a sine graph. So be aware that there is no single right answer for these, and you may be asked for this one, for example, to write a sine function rather than just a cosine function for it. But let's go ahead and start with writing a cosine function. So let's start writing cosine. And first thing we need to do is start picking out our information. So very first thing here is we can see how high we go above the x-axis or above our equilibrium position here, this little central part that it's rotating around. And we basically have an amplitude equal to 2. So immediately I can go ahead and write 2 times the cosine of something, okay? Now, we have no vertical shift occurring because we're still, the wave is still oscillating around this x-axis, this red line I put here. So this will be a plus 0 out here. We can look at the period by going through one full cycle, peak to peak. And if we look at this, this is occurring over a distance from 0 to 2 pi. Therefore, the period equals 2 pi. Okay? And remember, if the period is equal to 2 pi over b. So in this case, our period is 2 pi equals 2 pi over b, which means ultimately that b equals 1. And so we can plug that value in. We can go ahead and plug in 1 right there. Next, we put in our x, and then we look and see what kind of a horizontal shift do we have. And here we basically don't have to have any kind of a horizontal shift, so we can put a 0 there. Now, if we go ahead and simplify all of this, all we end up with is 2 cosine 1 times x minus 0. X minus 0 is just x, and 1 times it is just x, and a plus 0. And this is a graph of 2 cosine x. Okay? So there you go. That one is done right there. Now, I want to do this next one. I'm going to do it as cosine again. Now, this kind of looks like it's a sine function because it's starting at 0, 0, but we're going to do it as a cosine, just so you can see that we could do this one as a cosine. So again, first thing we want to do, let's look at amplitude. Amplitude is right there. We're going all the way up to 1, therefore amplitude equals 1. So the first thing I can do is write 1 cosine of something, and then times an x minus a something, and then plus a something. Now, we're still centered right on the x-axis, so this will be a plus 0 out here, no vertical shift. We've got, we have a period. If we look at the period again, this period starts here, or actually, we don't have to do peak to peak. We can say the period starts here and ends over here. So in this case, we again have a period equal to 2 pi. And therefore, we end up with, just like before, b equals 1. So we can put a 1 there. Now, here's the part we have to worry about. This is supposed to be a cosine function. Well, cosine functions, their peak is supposed to be right here. It's supposed to be a graph that looks like that. Okay? Let me do that in a different color, just so it's a little more visible. It's supposed to be right here, and it's supposed to look like that. But we're not there. We're shifted to the right. All right, you see that? So we're shifted to the right, and that point right there is pi over 2. So we're actually shifted to the right pi over 2, which means we need to subtract pi over 2 right there. Then the only thing left to do is actually combine this. 1 times cosine is cosine. We have 1 times x minus pi over 2. That's just x minus pi over 2. And then plus a 0 is just a 0. Okay? So essentially right there, we just basically graphed a sine, but as a cosine. All we had to do is just shift it horizontally, and we can basically swap back and forth between the two of them. All right, let's take a look at one more, and then I'm going to leave the last ones for you to try. So let's actually go ahead and make a sine graph out of this one. So here, let's make a sine graph. All right, because you might be asked to. So the first thing we can look at is, well, let's figure out where is our equilibrium. Well, this goes right through the center. So that's going to essentially be our x-axis for the moment. And we need to start looking at some stuff. So let's start by looking at the amplitude. We go a distance 1 above there. So our amplitude, again, equals 1. So we have 1 times sine. Then we need something x minus something plus a something. So let's figure out what all these things are. So we can go ahead and look at the period. Or wait, what did I look at first before? Oh yes, the vertical shift. If you notice, the original sine function, if we just sketch it in here real quick, the original sine function looks like this. Okay, and so we are centered right here, and if you look, that center drops down by 2. So we have a vertical shift of -2. That means this is a -2 right there. Next, we want to look at what the period is, right? Here is a starting point, here is an ending point, this is our period, and we're still going a distance of 2 pi, from 0 to 2 pi. So again, the period equals 2 pi. So just like the ones up here, just like this I did right here, if the period is 2 pi, then we're going to end up getting b equals 1. So I can go ahead and put a 1 right there. Next, I need to look for any horizontal shifts. If you notice, this peak is over here, whereas the peak up there is shifted over to the side comparatively. That means we had to actually shift this peak back. This is a pi over 2 location, so we've shifted it backwards. We shifted it left pi over 2, which means we need a plus pi over 2 right there. And once we've done that, that's it. And we can write sine of x plus pi over 2 minus 2. Okay? And there's that one in sine. Next, if you had wanted to, you could have done this as a cosine. You just wouldn't have had a horizontal shift. I'll let you give it a try. Try writing it as a cosine. And what you should get is cosine of x minus 2. So writing it as a cosine turns out to be a little bit simpler. You just are missing that phase shift right there. Okay? That's the only thing that you're missing at that point. Okay? So go ahead and try this next one. See if you can get it done. I'll complete it in the notes for you so you have it. And the same thing for these ones on this page. Give them a try and see if you can get them done, and then take a look at the notes to see if you get it correct. All right, that's pretty much it for now. Let me know if you have any questions.